Hey everyone! Today we're diving into the fascinating world of aviation. We see these giant metal birds soaring through the sky all the time, carrying hundreds of people, tons of cargo, and my oversized luggage. Just kidding, mostly. But have you ever stopped to really think about how it all works? How does something so incredibly heavy, something that looks like it should be firmly planted on the ground, just fly? Ever wondered how those massive planes manage to take off and stay in the air? Well, you're in for a treat. We're going to break down the science behind flight into bite-sized, super understandable pieces. No complicated physics lectures here, I promise. Just the cool stuff, the aha moments, and maybe a few mind-blowing facts that will make you look at airplanes in a whole new way. Next time you're at an airport or gazing up at the sky, we'll explore the forces at play, the ingenious designs, and the careful calculations that make air travel possible. So buckle up, metaphorically speaking, unless you're watching this on a plane, in which case, buckle up for real. We're about to embark on an aerodynamic adventure, uncovering the secrets that allow these magnificent machines to conquer gravity. We'll talk about wings, engines, and even the way a plane tilts. By the end of this, you'll not only know that planes fly, but how they fly. And you'll be able to impress your friends with your newfound aviation knowledge. Let's get ready for takeoff into the world of flight science. Let's dive into Bernoulli's principle. Daniel Bernoulli, an 18th century Swiss mathematician, discovered something cool about fluids. Air, like water, is a fluid. Bernoulli's principle helps us understand how wings generate lift. Faster air over the wing means lower pressure. Slower air below means higher pressure. This pressure difference creates lift. So we've got lift, thanks to Bernoulli and those awesome wing shapes. But a plane sitting still on the runway, no matter how perfectly shaped its wings are, isn't going anywhere, right? It needs a forward push. And that, my friends, is where the incredible power of engines comes into play. Engines provide thrust, the force that propels the airplane forward through the air, overcoming drag. Without thrust, there's no airflow over the wings, and without airflow, there's no lift. Think of thrust as the airplane's go button, its motivation to move. There are different types of engines, but the most common ones you see on big commercial jets are, well, jet engines, specifically turbofan engines. These things are marvels of engineering. They work by sucking in huge amounts of air at the front with a massive fan. A portion of this air goes into the engine's core, where it's compressed, mixed with fuel, and ignited. This creates a super hot, high-pressure blast of gas that shoots out the back at incredible speed. This is where another famous scientist, Sir Isaac Newton, and his third law of motion come into the picture. For every action, there is an equal and opposite reaction. The action is the engine blasting hot gas backward at high velocity. The reaction, the engine, and therefore the airplane it's attached to, is pushed forward. It's like letting go of an inflated balloon. The air rushes out one way, and the balloon zips off in the opposite direction. Jet engines are just a tad more sophisticated and powerful than that. But it's not just the core that's working. Remember that giant fan at the front of a turbofan engine? A large portion of the air pulled in by this fan actually bypasses the core. It's ducted around the central combustion chamber and then accelerated out the back. This bypass air produces a significant amount of the total thrust, especially at lower speeds like during takeoff. It also makes the engine quieter and more fuel efficient than older, pure turbojet designs. We've talked about the basic shape of the wing and how engines give us thrust. But airplane wings are even cleverer than they first appear. They have some secret weapons, some moving parts that help them perform different kinds of magic, especially during the critical phases of takeoff and landing. I'm talking about flaps and slats. These are like the wing's adjustable settings, allowing pilots to change the wing's shape and performance on the fly, literally. So, what are flaps? If you look at the trailing edge of an airplane wing, that's the back edge, you'll often see sections that can extend downwards and outwards. Those are the flaps. When a plane is taking off or coming into land, it's moving at slower speeds than when it's cruising at 30,000 feet. At these lower speeds, the wings need a little extra help to generate enough lift. Deploying the flaps effectively increases the wing's curvature, or camber, and also increases its surface area. By increasing the camber, the flaps make the wing even better at accelerating air over the top surface, just like we talked about with Bernoulli's principle. This means more lift, even when the plane isn't going super fast. Think of it like giving the wing a temporary boost in its lifting ability. This is crucial for getting a heavy plane off the ground with a shorter runway, or for allowing it to fly slowly and safely during approach and landing without stalling, which is something we'll talk more about later. Now let's move to the front of the wing, the leading edge. Here, you'll find another set of clever devices called slats. Slats are small aerodynamic surfaces that, when deployed, slide forward and often slightly downward from the leading edge of the wing. This creates a small gap, or slot, between the slat and the main wing. Let's dive into a crucial flight concept, the angle of attack. It's the angle between the wing's chord line and the oncoming airflow. This angle controls the lift generated by the wings. Increasing it boosts lift, crucial for takeoff. But there's a limit. The critical angle. Exceeding it causes airflow separation, reducing lift and increasing drag. We've covered how planes generate lift and thrust, and how they use clever wing parts and angles to control their flight. But there's another absolutely critical factor that pilots and engineers obsess over: weight and balance. You can have all the lift in the world, but if your plane is improperly loaded, it can become unstable, difficult to control, or even dangerous. It's a true balancing act, and getting it right is paramount for a safe and efficient flight. First, let's talk about weight. Every aircraft has a maximum takeoff weight, a limit set by the manufacturer that cannot be exceeded. This includes the weight of the aircraft itself, the fuel, the passengers, the crew, and all the cargo and baggage. Why is this so important? Well, lift has to overcome weight. The heavier the plane, the more lift is needed, which means higher takeoff speeds, longer runway requirements, and more stress on the aircraft structure. Exceeding the maximum weight is a big no-no. But it's not just about the total weight, it's about where that weight is distributed. This brings us to the concept of the center of gravity, or CG. The CG is the imaginary point where the entire weight of the aircraft is considered to be concentrated. For an aircraft to be stable and controllable, its CG must be within a specific range, also determined by the manufacturer. This range is often quite narrow, so precision is key. If the CG is too far forward, too nose-heavy, the plane will want to pitch down. It might be difficult to raise the nose for takeoff or to flare for landing. The controls will feel heavy. Conversely, if the CG is too far aft, too tail-heavy, the plane will want to pitch up. This can be even more dangerous, as it can make the aircraft very unstable, difficult to control, and more prone to stalling. The aircraft might feel overly sensitive to control inputs. And there you have it, folks. A whirlwind tour through the amazing science that keeps those incredible flying machines up in the sky. From the subtle pressure differences created by Bernoulli's principle and the sheer power of thrust from the engines, to the clever adjustments of flaps, slats, and the crucial angle of attack, it's a symphony of physics and engineering. And let's not forget the vital importance of getting that weight and balance just right for a smooth and safe journey. It's truly mind-blowing when you break it all down. I hope you enjoyed these fun facts about how planes fly and take off. It's pretty cool to think about all the invisible forces and intricate designs working together every time a plane gracefully lifts off the runway and soars through the clouds. Hopefully, the next time you're on a flight or just see a plane overhead, you'll have a whole new appreciation for the marvel of aviation and the incredible human ingenuity that made it all possible. Knowledge is power, and in this case, it's the power to understand how we conquer gravity. Don't forget to like, comment, and subscribe for more interesting videos. Let me know in the comments what part of flight science you found most fascinating, or if there's another topic you're curious about. We love hearing from you and exploring these amazing subjects together. Thanks for watching, stay curious, and as always, keep looking up. See you next time.